Hello friends, in this tutorial we will learn about confusion matrix. Now what is that matrix? Now let's see. A confusion matrix is a figure, or we can say a table, that is used to describe the performance of a classifier. Now in our previous tutorials we have learned about classifiers, different classifiers like naive Bayes classifier and LR classifier. Now in that, we have to find out the performance of those classifiers, and for that we are using a confusion matrix that can be a figure or we can say a table. It is usually extracted from a test dataset for which the ground truth is known. We compare each class with every other class and see how many samples are misclassified. Now we have different classes in our classifier, and then we will take each class and then we will compare that class with every other class, and then we will see that how many samples are misclassified, that is they have wrong placed. So using a confusion matrix we can describe the performance, and that was the technique, that is comparing each class with other classes to get the output. Now see, during the construction of this table, we actually come across several key matrices. Key matrices, that is those matrices which will be given as an input for comparing. Now let's consider a binary classification case where the output is either 0 or 1. So let's see an example. In that we have output is either 0 or 1. So there will be 4 different cases. Now first case is true positive. These are those samples for which we predicted 1 as the output and the ground truth is 1 2. Next is true negative, in which these are those samples for which we predicted 0 as the output and the ground truth is 0 2. So that is your true negative. Output is 0 and ground truth is also 0. Now false positive, in that these are those samples for which we predicted 1 is the output but the ground truth is 0, and that's why it is false positive. So this is also known as a type 1 error. Next is your false negative. These are those samples for which we predicted 0 as the output but the ground truth is your 1, and that's why its name is false negative, because you are getting 0 but the ground truth is 1. This is also known as type 2 error. So these will be your 4 different samples in case when output is either 0 or 1, and that is actually representing your confusion matrix. Depending on the problem at hand, we may have to optimize our algorithm to reduce the false positive or the false negative rate. Now, depending on the problem, we have to make our algorithm such that we have to reduce your false positive or false negative rate, because if we are getting more false positives or more false negatives, then it will be not beneficial for us. It will give wrong answers. For example, in your biometric identification system, it is very important to avoid false positive, because if you are getting more false positive, the wrong people might get access to sensitive information, which is our which is our confidential information, and that will be going to the wrong people. So that is the case here also. So we have to optimize our algorithm for so that we can reduce our false positive or the false negative rate. Okay, so let's see how to create a confusion matrix using a Python program.